All right. Hi everyone, and a huge welcome to all of you. I am most humbled that so many of you decided to spend your Tuesday with me. Um, awesome, really. Now, I recognize a few faces, but not that many, which I think means that you don't recognize me either. So, just a quick introduction then. I've been in the software industry now for about 18 years. I started out in telecoms, mobile, transitioned over to enterprise kind of software about 10 years ago, and for the last 5.5 years or so, I've been fortunate enough to work with a company called Factor 10. That's us. Um, we do software consultancy in maybe a slightly different way. My passion as a developer or as an architect or as an engineer, I found out over the years, is not really that much about the tools. It's not really that much about the code either in itself. It's about business value through code or through the tools, if you like. And I found a company that sort of shares my oops, I haven't actually started this yet. Actually, let's keep it that way. I found a company who really shares that mentality. So what we do basically is that most of the time, we do short assignments for various companies who've ended up in a situation where something's gone wrong, basically, with their code base. They find out that the changes they want to make cost too much, take too much time, require too many people involved, and they need to understand why. It's not seldom that there's management typey people who think that they have a problem with their engineers, and so they think that they'll hire us to confirm their suspicions so that they can do whatever changes they need to do to their engineering staff later on. You might guess that that's not always the case. Usually there's a problem in many places and not necessarily with the engineers. Sometimes, however, it's also down to how the code is written, and maybe we'll go in and help with a way out of that mess. So, enough about that. Let's see if we can get this going here. Now, I've realized that this is a huge problem. This is a big screen and the resolution is high. So you can actually read all of it right now. And that wasn't my intention at all. But I'll just go into the first slide here and try to set the stage, basically, for what we're going to talk about here tonight. And there's a guy called Simon Sinek who wrote a book. Anyone know what it's called? Starting with Y, I think. It's not bad. I don't think he claims to have patented the idea of figuring out why you do something, but it is a good idea, and it's a good thing to keep in mind. So setting the stage here. Actually, did you know that he came out with a new book now? It's not called Why anymore. It's called Purpose. Very confusing. Anyways, let's start with you guys and with me, I guess. I hope that you all came here thinking that hopefully Anders will give you something that I can bring home with me that gives me some sort of value for my business or whatever it is I do during the daytime. And that is my hope as well. I think that if you all leave here with at least one thing that, I'm going to have to remember that one, then I'll be happy, and I hope you guys will be too. This is not an introduction to microservices. That's not the intent. It's not exactly a cheat sheet either, but it is a collection of my experience, or some of it. condensed into to some food for thought, basically. I don't really know exactly what all of you guys do on a daily basis. I had the opportunity of asking some of you before we started, but I don't know what all of you guys do. For example, how many of you in the audience here right now mainly write code on a daily basis? Wow, that's almost all of you. How many of you would have architect on your card? More or less, yeah. Awesome. How many of you are responsible for a team? And does that also include hiring and strategy, basically, for that team? Okay, cool. So that makes me happy. There's a little bit of everything here, because the things I'm going to talk about aren't necessarily all technical. And there's a reason for that. I don't think, as I mentioned earlier, that technology necessarily is the question and the answer to every problem, basically. So the next point about why is that I'd like you guys to sort of connect what I'm talking about here to your needs, to your business, to what it is that you do on a daily basis. So I'd like you basically to ask yourself the question: well, what are your business needs? What really matters to your business? And that's strongly connected to your why. And it's a favorite question. Whenever I go to any client, this is basically the first question I ask them: why are you in business? Why are you doing the things you do? Because if I can't understand that, then it's going to become very difficult for me to give good advice about which direction to go, if I can't connect it to their actual purpose. So that needs to be answered in your context, basically. And it's surprising actually how many companies don't know this. The number one response you might get from that question, why are you in business, is to make a lot of money, to make profit for our shareholders, and yes, that is a part of it. And it's it's always going to be, unless you're some kind of funky foundation or something, it's going to be part of it, obviously. But it's not your why. It's not. If that's the only reason you have for existing, I would suggest you're going to fail, basically, sooner or later. As an example, a popular thing, I don't know if there's any right outside right now, electric kick bikes. They're a hot topic nowadays, and let's say we wanna start a company that rents or loans or lends electric kick bikes. Our why might not be to make a lot of money out of that. Our why might be to disrupt urban transportation through kick bikes, for example. And once I know that makes it easier for me to relate to what actually needs doing and talk about what do we need to do in order to achieve that. Okay, we're gonna need some way we're gonna have vehicles, obviously, kick bikes, that's fairly obvious. We're gonna need to manage them somehow, but that's not enough. We also need to manage how we bring money in from our customers. So we're gonna have some sort of lease system that keeps track of, everyone has an app in their phone and they can just press a button and grab a kick bike, and we need some sort of system to manage that. That's what I want to talk about. I am in no way interested in what database you're going to use to store it in. It's a question of essential versus accidental complexity, basically. And it's just something I'd like to keep with us during the topics that we're going to talk about here, that there's a very much a difference between essential and accidental complexity. The essential complexity might be around how do we manage these leases in a way that we get the maximum turnaround on our kick bikes. And we might need to figure out some funky algorithms for that. Who knows? I don't know. We're not going to do that tonight. Accidental complexity is about how do we transform our objects from one end to a database or whatnot. It is entirely uninteresting to the business, basically. And once we figure this out, once we know that we need to build something that has to do with kick bikes, and we need some kind of way to manage leases, we need to figure out how that aligns with our architecture roadmap. Ooh, an architecture roadmap. Do you all have one? No? Does anyone have one? If not, I think that's one thing you might take with you then. It's a good thing to have because you're gonna have hopefully a product roadmap that sort of figures out that we need to do. Okay, we'll do the inventory for the kick bikes first, but then we need to do the leases in order to have a minimum viable product. And we can maybe wait a bit with the back-end reporting systems that are going to give us nice reports for the board. That's not crucial to begin with. So we'll put that at the end of the roadmap. But in doing that, we need, or I think it's a good idea, I should say, to shadow that with an architecture roadmap to sort of figure out how are we going to support these business needs. What is it that needs to be built in order to realize that vision? And the one thing that I'm going to mention quite a few times tonight is cost of change and time to market as considerations for that architecture. This nice graph here is does better on a white background, I should say, because there's actually a very faint line going up there, which is, I think it may be that Kent Beck drew this curve once upon a time, but it basically states that over time, as you add software to your code base, the cost of any change will gradually start to increase, and at some point you're going to end up in an exponential curve which is sort of where companies come to us and ask, oh dear, how did we end up here, and what are we going to do about it? What we want, obviously, is to avoid that trap and achieve a curve that will sort of almost level out over time. It's never going to be flat. If so, then we've stopped adding software at all. But we sort of want it to level out as much as possible. That's a code base that's going to survive more than one product iteration. And I don't necessarily mean a number of years. I mean how much do we allow our business to change their needs and support that through our software. That's the number one factor, I think, for it's why we exist, basically, to support the business with tools that help them realize value. And most businesses actually change over time. If they don't, well, I'd suggest they're probably going to fail too. Most of them actually do, and those changing requirements are quite often, unfortunately, met with the response that no, we can't feature. We built this system to handle these kinds of requests. Those, crazy. We'll have to start from scratch. It's not doable. Unfortunately, it's quite common. So, time to market and cost of change. Keeping cost of change low in order to keep time to market short is my number one priority whenever I do any sort of software. So we figured out that we needed something here. We're going to build something, and why not microservices? It seems to be popular. It's a cool buzzword. Everyone for the last 5 years or so, at least say they've been doing it, and for the last 10 years, it's been quite popular. So let's think about it for a few seconds. Maybe we'll do a service to manage our bikes, our vehicles. Yeah, that sounds like a good idea. And maybe we'll do a service to manage leases, because those things, well, yeah, that sounds like two different things. Let's just start there, basically. So the next step on our path here is trying it out with microservices. The question that I'm proposing to you is that the silver bullet? Is that what's going to keep us from ending up in a code base that where the cost of change goes up? Does anyone think so? No, me neither. It does have nice pros, and these are just a few of them. It's funny that I sat down to think about what are the pros actually, and I'll start from the bottom here, because scalability is one of the ones that are often mentioned. If we are gonna build something big, and quite often people tend to think big. It needs to be big. This is a big thing we're doing, so obviously it has to be big. We need a lot of people involved to do this. And everyone knows that putting too many people in the same room together will end up going nowhere, basically. So we need a way to compartmentalize our teams, or basically to split our people into teams. And microservices promises to deliver on that, where different teams can work independently on different parts of a whole, and there you go. Scales horizontally. Just create more services, basically, and you can create more teams, and off you go. It is true. It does solve that problem, but we'll get into later why that can also be a problem. Coupling and cohesion, basically the first things I learned about in object-oriented programming many years ago. You want low coupling, you want high cohesion, you want separation of concerns, you don't want one thing messing about with the internals of another thing. And then microservices sort of promise that too. Ish. You can still mess it up, but if you do it right, supposedly, it will work for you. Let's see here. Just a sec. A question though is, how is this different from a well-designed modular monolith? Ooh, I said that word. Maybe it is, maybe it isn't. Because when it comes to the cons, and people have been starting to mention them, it gets popular to, whenever something gets too popular, it gets popular to have a different opinion about it, basically. So a guy named, where did that go? No? Doesn't want to play along anymore. I'll just do this then. A guy named Dave Kerr wrote a really nice blog article called "The Death of Microservice Madness" in 2018. And you you might think that that Dave has a critical view of microservices. Not at all. At least that's not my interpretation. But he does bring up some very good points about the pitfalls and about how it's not a silver bullet or a one jack of all trades that'll do any trick. People might argue that complexity becomes an issue. We get more things, and thus we get more complexity, you might say. See, I put a little question mark there, because this is a philosophical thing for me. Is that true or not? Well, I guess it depends a little bit on how you look at it. In a way, your system is going to have a number of parts. We'll have a part that deals with the bikes, and we'll have a part that deals with the leases. Regardless of whether we separate those two parts by process boundary or an HTTP protocol, or if they're running in the same thread. That doesn't necessarily mean that things get more complex, in my mind. It could be though, and especially if you go about making them in different ways. What else? Latency. Yeah, sure. If that's a problem for you, it's for sure it's going to take a longer time for signals to travel between your services if they're separated by physical machines rather than running in the same process, obviously. But is that a problem? Usually, I'd say no. Doesn't have to be. Tooling, another one. And that, I think, is mostly true. It's gonna require probably a little bit more tooling than if everything is in the same stack. But again, what does that mean in terms of quantity? Well, that's really up to you. Consistency is perhaps another question that gets mentioned. Consistency across services, so on, is a popular topic. With oftentimes you have an event-sourced architecture backing your microservices, for example, and people might say that no, this is a banking application. We can't have eventual consistency. That's impossible. Maybe not. Doesn't necessarily have to be so. So, I'm probably taking way too much time here. Coming up then, 4 service design considerations ending in Y. This is where you laugh, because it's a pun on why, you know, the importance of why, yes. Okay, no, maybe not. And then sort of connected to that, 4 lessons. Well, those are the considerations basically, but 4 lessons that I've learned. So we'll start off easy with the topic of, it worked, granularity. So I've tried to organize these into a statement about a promise from microservices, and then there's going to be a trap, and then I'll talk about how maybe you can avoid that trap, sort of. So the promise here, as I mentioned earlier, is that we can put different teams on different services, keep them separated from each other, and scale as far as we want, horizontally, basically. And this has reached some epic proportions in some cases. It's the trap, I should mention before I go on perhaps, is as I see it, is growth for the sake of growth. Now this is not a technical consideration. This is very much an organizational consideration and a strategical consideration perhaps, but nonetheless it's important. Why do successful companies, especially those who get a lot of VC funding, think that we need to grow as big as possible? It happens over and over and over again. And boy, do they love microservices. It's perfect, because it allows them to do so. We can have 150 teams. Perfect. And okay, that probably means that we need to have 150 microservices then too. At least, because they can't work on the same one. But the question you should ask yourself is, how many do we actually need? This shouldn't really be a question. This is a bit of a warm-up, basically. Martin Fowler and James Lewis and Conway as well have some opinions about this. They wrote about it. Don't be silly. Organize your organization. You say that? Well, I did. Around business capabilities, not around your activities. If you end up organizing your teams according to what they do, then that's what you'll get out of it in the end. Whereas if you organize them around the goals that they need to achieve and the business needs, then that's what you're going to get out of it in the end. Conway's law states something in the sense that your software is going to reflect your organization, basically. And it's one of the very few laws, I think, in software that's usually true, and a little bit scary as well. So what does that mean then? Well, another take on it, on this problem, is that one of my favorite things is domain-driven design. I think it applies extremely well to most of the problems that I work on. And so I thought to myself, how can domain-driven design help me here? Well, it does have some ideas about what we mean by business capability. And by that, I mean that there is in domain-driven design the concept of bounded contexts. Is anyone familiar with it? Have you read Eric Evans's book? If not, I think you should. It's awesome. So a bounded context is basically if you do a mind map of all the concepts that we have for our electric kick bike company, we're gonna have one part where it's the bike and the wheels and the stickers and the batteries and all the physical things that's connected to the vehicles, basically. And we're gonna have another bunch of words where we talk about customers and billing and whatnot. A bounded context is basically the natural way to organize those parts separately from each other. The stickers and the batteries are entirely uninteresting to the logic that deals with your customers and their leases, and vice versa. So I tend to think about that in bounded context then. So it makes sense to have your vehicles separate and as a separate service, because that might have different requirements than your service dealing with your leases or your billing or whatnot. Vice versa, I work a lot in the financial sector. The term contract, for example, is a very common idea in that domain, regardless whether it's insurance or banking or whatnot. Contracts tend to sort of stay a bounded context because there's a lot of details within them. There's a lot of parts that go into a contract, and they might be organized in different ways and so on and so forth. But the internals of a contract are usually entirely uninteresting to the other parts of the system. The rest of the system usually only wants to know the output, basically, the bottom line of the contract. So we'll keep those separate. Whereas, on the other hand, it's probably not a good idea to design a service for each and every part of your kick bike. The stickers, well, they could have their own service. Why not? We have sticker management, the service, and batteries could have their own, and so on. I don't think that's a good idea. And just to name drop a little bit, Neil Ford made me happy the other day when he tweeted that orchestration problems are actually most often granularity problems. So people tend to complain about the difficulties of orchestration in terms of microservices, but he claims that, well, you've got your granularity wrong, actually. You probably got too many services. Excellent point, Neil. That's sort of what I wanted to say, but in a very condensed way. Okay, moving on. What's next? Integrity. So, again, the promise. You can do whatever you want with your service, as long as you maintain a strict protocol at the boundary, so to speak, between your services. But as long as you do that, then you can do whatever you want inside your service. That's sort of the promise. And one part of that is that you can, for example, you can pick your own database solution. If your particular service happens to have a very, let's say, graph-oriented domain model, it might make sense to use a graph database for that particular service, whereas it doesn't at all for another service where a key value store might be the most efficient way to store your data. I'm talking about databases. I said I wasn't interested in them, but still, that's the point to make there. The trap is that I'll take that back. Someone might take a shortcut, and this, unfortunately, is quite common as well. As an example, I'm just going to have a quick look around. Nope, no one here that knows me from before. No, actually, I'll stay there for a little while. One customer has an off-the-shelf system that they use for managing contracts. Actually, what do you know? And they thought, well, how hard can it be? Contracts, you know, someone has invented that. So they bought that system, or they rent it, or whatever they do. And it has a database, and they figured out pretty quickly that actually it didn't do all the things that they needed as a business from that contract system, but they'd already paid that humongous license fee, so we'll adapt. We'll add some tools on the side, we'll build, add to it. Actually, we can't change the product, but what if we just take the data out of it, and we'll do something with that. We'll do the basic workflow with the system, and we'll build other things outside. 126 different integration points directly into the database. They ended up with a project to upgrade that system. And yeah, you're laughing, yeah. You can see what happened. 5 years is what it took. I'm not sure they're actually fully done yet. The most important parts of those 126 dependencies have been resolved, but not all of them. So the solution then to that problem is obviously to stick to that strict protocol. And for some reason, someone in my company came up with the idea of eggs, and thought that was a good analogy to microservices done right, sort of, because an egg has a very hard shell, and that's really all you need to know about it from the outside. You don't get to care about what's going on in the inside of it. The only thing that you need to consider as a consumer or producer to that particular service or egg is the interface that it provides you with. And you stick to that interface. You do not integrate directly to its database, because things are gonna go south pretty quickly. And it's tempting. The usual argument would be performance. Oh, it's going to be so much quicker to just go to the database. It's right there. I have the connection string. Why can't I do that? And then it'll happen. And who knows? Sometimes it might even be the right thing to do, depending on how long you think your solution is going to live and so on. Right, moving on. I'm way over time. But we're moving on to number 3 then. Now we're getting into my sort of favorite subject, so these I'm going to talk about a lot. Testability does not follow the pattern here. There's no promise and no trap. This is just important, basically. We'll start with the problem then. The more parts we have, the harder it's going to be to integrate them. And yes, I do believe that's true. It just is that way. The more and more things we add together, the harder it gets to orchestrate them, as Neil Ford commented as well. They need to behave correctly together, and where we would normally, where we would normally handle that with a lot of unit testing, we may find ourselves in a situation where we can't to the same extent anymore because we've separated parts that we would otherwise unit test. Now, actually, I think it's a good thing. Oops, no, let's back that up. I think that's a good thing because if you were able to unit test it before and not integration test it, regardless if everything was in the same assembly, if you were able to unit test it before, it may be that you didn't have the proper separation between your modules anyway. An integration test can absolutely live within the same assembly and run there as well. But my point that I'm going to make here anyways is that integration testing becomes a little bit more important. And now I'll click us through to where I actually make that point. So back to the idea of a short time to market. If we imagine a point where a business person conceives an idea, a business idea, of a brilliant idea of how we can make more money for our business. And the other end of that string is when it's actually realized in production. For me, that's my number one KPI, basically. How can I keep that as short as humanly possible? Well, continuous delivery and continuous deployment, for that matter, is often touted as a good way of achieving that, and I do think it is. What we mean is basically that we want to automate as many steps as possible between here and here, because any part that requires human intervention is going to cost time, and time is what we don't have. So we'll automate all of those parts that we can automate to our best ability. And does anyone here work in a company where you can say that you have this down? It's working perfectly and a very short time from inception to realization. Anyone? Nope, it's not that common. So no need to to be ashamed about that. This one is maybe my favorite picture. The test pyramid. It's one that always works. Whatever problem you have with your software stack or organization or whatnot, this guy right here is probably going to help you. That's why I love it. It basically tells us that in order to realize continuous delivery, in order to be able to achieve a fail fast, and by that I mean that whenever an error is introduced, we find it as quickly as possible, preferably before code is even committed and pushed into to Git or whatever, but for sure before it's actually built into a deployable artifact. So we need to find our failures fast, and when we actually fail, we need to and we want to do it in a way that we can keep our momentum rolling forwards. If I introduce a change in system A, in the vehicle subsystem, if you like, or microservice, that breaks my integration contract with the leases microservice, that can happen quite easily. I've changed something in the model of my vehicles, and all of a sudden the leases service no longer can pick up something from an integration point in the other. I need to find that out as quickly as absolutely possible. This is exacerbated by microservices for sure. So my point being that we need to put a little bit more emphasis on the integration test than you might normally do, but the pyramid here is still meant to represent sort of the relative amounts of tests that I think you need. It's not uncommon when I meet clients that they have a very long string from inception to realization. And they think that the solution to that is to remove the manual testers by replacing them with end-to-end tests. Basically, if the testers are clicking, following a test manuscript in the UI, then we'll just replace them with a script to do the same thing, and surely everything will be fine. And my message is no, it's not. It's a band-aid. You might get a little bit of an effect out of it, but unless you have a solid foundation of unit tests from the bottom up, with an amount of integration tests on top of that, and the number depends basically on the number of modules you have in your system. And then sprinkle that with a few end-to-end tests on top to make sure that everything works when you stack the UI on top of it as well. Then you're never going to realize your continuous delivery dreams, basically. To put it into numbers, usually for me, if we look at the leases, microservices that we talked about here, for example, I might expect there to be thousands of unit tests. And I would probably expect there to be hundreds of integration tests, and I would probably expect there to be tens of end-to-end tests. That's the relative size of them, basically. Another important thing, I'm just going to blow right past my deadline here. I hope that's okay with you. Another important thing is that if you're going to realize this, you absolutely have to have known test conditions. The number one killer when it comes to integration tests and end-to-end tests that I've seen is that you have a very complex system. Every one of your services will have their dependencies. You have this one who needs a SQL Server instance running that needs to be considered just like that, and this other guy here, he needs this and that, and so on and so forth, and they need to be brought up in the right order, and they need to connect to each other, and they need to be prepared for your test. When you're testing your service, you need to know that the other guys around you are in a very known state in order for that test to work. If you don't, you're going to get false negatives, and at some point, those false negatives are going to lead you to the point where you stop caring. And this fails, basically. I've seen it quite a few times. In order to realize that, you need, I think, a way to push a button and get a fully working environment spun up on demand. It's not easy, but I think that with the advent of containers and Docker especially, it's now quite doable. I've gone through this right now with a customer actually, and we're extremely proud to say that we can go from nothing to booting up, I think it's 15 or 16 different services, including databases and everything, in the right order, getting it all up and running a suite of integration tests, let's say 100 of them or so, in under 2 minutes. Yes, that's aggressive. 10 minutes would have been fine, but it's nice. Anyways, I think this is a killer thing. Actually, it's a deal breaker. If you don't get your continuous delivery pipeline working, then the risk is that your time to market is gonna grow instead of shrink, basically. Okay, then moving on to almost the final slide. Whoop, here we go. Yes, conformity. The last word ending in Y. This is also a good one. I like this one. So the promise is that you can pick. Well, I've mentioned this a few times by now, but you can pick whatever tool you want. And let's take programming language as the example of that. Why should we care what the other team thinks about C# or Kotlin or Ruby or whatever it might be? We'll do our thing, you'll do your thing, and we'll just keep to that strict protocol that Anders was talking about on the integrity slide, right? And everything is going to be hunky-dory. And yes, that's sort of sort of true. The trap here is that you make your, and I'm saying you again, that's not fair. Someone makes their decisions based on technological preferences rather than business value reasons. We think that this happens to be a nicer tool, so we're going to use that. And you'll get a lot of arguments about which languages are easiest to recruit for example. And that might be a consideration, absolutely. But what I'm 100% sure about is that you do not want to end up with in a company with 150 microservices that are all done in different technology stacks. That's going to be difficult to maintain in the long term, for sure. Getting a bit philosophical again, I tend to think about what we do as developers as a game of abstraction, basically. I get a task, I get a business need to realize into software, and I need then to think about what level of abstraction is suitable for this particular problem. In order to do that, I need to think about the total cost of ownership of that piece of software. Is this something that's it's a database migration script? It's fire and forget, or is this the core business module of your enterprise or of your business? How often are we going to need to be able to change this, and what's basically the price performance ratio of various things here? Now, I might argue, actually, we're getting into the next slide a little bit here. I might argue that these are things to keep very much in mind when you think about what technology stack to choose for your system, because I'll get to that point shortly. You need to follow the protocol. Regardless of which tech stack you choose, you still have to play nicely with everyone around you. You need to communicate with your outside world. You need to follow the rules that your operations engineers have set up, and so on and so forth. And we've not even mentioned DevOps here, but if that comes into it, and it usually does when microservices are a topic, then yes, you need to think about the DevOps considerations, basically. So, how do we solve that then? Well, I call this one the paved path. We've established that it's awesome to have freedom to choose what you want, to do what you want within your service, but it comes at a price. We learned from the integrity slide that there's a strict protocol that you need to adhere to. We learned from the granularity slide that orchestration can be tricky if we have too many of them, or if we have different tooling for them. We learned from the last slide that we have a bunch of, I call them nesses and illities. What are they? Liveliness, readiness tests that your orchestration tools, your Kubernetes or whatever, needs to be able to perform on your service, so that you know whether it's doing what it's supposed to, so you don't have to monitor that manually, but can use something else to do it. And we know that from the testability slide that we need to be compliant in terms of integration testing. What I mean by that is that when I'm testing my service written in, well, I'll say Kotlin because I happen to like Kotlin, and I'm testing it against your service that's written in C#. I still need a way for my service to tell her service that I need you in this particular state for this test. Please prepare yourself for my tests now. I need you to respond this, and that whenever I'm making these requests of you. So we need to be compliant anyways. And keeping in mind that all of these wheels, if we pick a completely separate tech stack will need to reinvent all of these wheels, basically. We can't ignore them. We need to conform to the rules of everyone around us. So there's quite an impetus actually not to reinvent those wheels if we don't need to. And in fact, what I think is that quite a few services in any given microservice architecture kind of do the same things. They manage oftentimes processes, flows, CRUD, and some sort of analysis and/or some sort of analysis, basically. That's what they do. That is to me kind of similar. So one thing you could do then is to build yourself a paved path for those services. This little picture here, this illustration, is intended to show you that if you're gonna cross a jungle and you have a choice between sticking to the straight path that goes through it and meandering off into the bushes, you can do both, and hopefully you'll end up at your goal in any case. The bonus of keeping to the paved path is that you don't have to reinvent all the wheels. You can get straight down to the business of your business. Whereas in the other cases, you'll need to think about all that accidental complexity that has really nothing to do with your business value. It's just technology that needs to be put into place for it to work. Your REST interfaces, your database layers, your whatnot. On the other hand, if you stick to the paved path, yes, your options are limited. You do not get to choose your language anymore. You may not even get to choose your database. And the point I'm trying to make is that probably that doesn't matter, because all you're doing in this particular service is processes and CRUD for some part of your domain. There may, however, be very strong cases for not doing it that way. For example, in one domain that I work in, in reinsurance, the contract is one thing, yes. That is very much a question of processes, flows, analysis, that sort of thing, CRUD. But we also do heavy simulations on those contracts, catastrophe simulations of tens and hundreds of thousands of basically simulations of a single year, where we, with stochastic models and things like that, try to figure out how likely is it that an earthquake is going to hit Stockholm, and if so, how much money is Trygg-Hansa going to have to pay out, and then how much are we going to have to ask them for in order to reinsure their property insurances and so on. That's a completely different beast. It's about heavy calculations. It's about massive parallelization and other things. So that doesn't fit at all in the same mold as the other things. So that one has to go through along the red path here, and it does get to see the nice waterfall that is our heavy parallelization and performance for that particular problem. But it doesn't. Most of them don't, basically. So the Roman Empire was built on roads, they say. It's how they expanded so quickly, because they had the paved roads that no one else did, so they can move their stuff around quickly. And I like that analogy. I think that you, as an advice, you should stick to your paved path unless explicitly motivated otherwise by your business. And how paved should your path be then? Going back to the other slide when I talked about that game of abstraction. Well, that is really up to you. I'd suggest start small, find commonalities, make sure to reuse them. But we have, on occasion, actually gone to the length of basically designing I'm not going to say low-code system, but a meta engine that consumes a semantic model basically a domain-driven design semantic model, where all of the storage and the search and the passing of stuff between backends and frontends and so on have been abstracted away by that engine. And it's actually quite suitable for some things. You get business value out the door extremely quickly. We've learned over the years that some things are not good ideas to do in that sense. We don't generate a UI, for example, from that code that was popular 10 years ago or so. That doesn't really work that well. It turns out that the UI of most systems are quite important in terms of business value, and you need to be able to differentiate it and so on. But you could go that far. Is basically what I'm saying. Start easy and try to reuse as much as possible, and try to basically keep a rein on the people in your organizations that see this as a chance to go crazy with new technologies and stacks. And that, 12 minutes over time, was that. Thank you very much.